Coming in hot with the Euclidean geometry, I need to complete the statement. Opposite angles of a cyclic quadrilateral are. Now, they're testing a certain theorem. They're asking, do you know that the opposite angles of a cyclic quad add up to 180? And there is a shorter way to say that. We can say that they are supplementary. And a nice way to remember it is like there's a hidden S in 180 degrees. So if angles add up to 180 degrees, we say that the angles are supplementary. And another nice nugget of information is if they are complementary, they add up to 90 degrees. And there's a hidden C in the 90 degrees. So in summary, the opposite angles of a cyclic quadrilateral are supplementary because they add up to 180 degrees. Okay, getting to the juicy questions. This angle is 25, that's been indicated there. O is the center, that's quite important. These points are on the circumference, and then first up I need to get D1. So D1 is over here. And D1 is touching a very special line. There's a sneaky weasel alert, but there's a radius on the loose. Again, I see another radius, which is going to make an isosceles triangle. So the base angles of an isosceles triangle are going to be equal for the following theorem. So if you have an isosceles triangle that has equal sides, you can conclude that the angles that are opposite the equal sides are equal. And your reason is angles op equal sides. So we're just going to say D1 equals 25 degrees for this reason. And your 1 mark comes from the statement and reason. And bear in mind, there's another reason you can use. I can say angles op equal radii. That's also acceptable. And next up, I need the size of O1. So I can see that O1 is an exterior angle of the following triangle. Triangle DOC. If I just extend this line DO, it encompasses the angle O1 between the triangle and that line extension. So we're going to use the following theorem. Exterior angle of triangle. And how it works is to get the exterior angle, you go to the opposite interior angles and you add them together and it gives you this exterior one. So applied in the context of this question, the opposite two angles are these 25s. So I add those together to get O1. And let's quickly go through how we're going to write that up. So O1 is going to be equal to 25 plus 25 for the reason of exterior angle of a triangle. And 25 plus 25 will just give me 50, my bro. And yeah, let's have a look where the marks come from. So you're going to get 1 mark for your statement and then 1 mark for your whale all reason. Next up, I need to get the size of A1. Okay, A1's in quite an abstract place. So how we're going to start off is we look at A1 and we follow it backwards to its chord or arc. So if I have a look at A1 and I look at the 2 lines that A1 is touching, I'm going to follow those 2 lines backwards and even more backwards until I get to the circumference, and it takes me to this imaginary chord. And then once I've identified my chord, I follow it down and down again, and it takes me to O1, to the center of the circle. So now I know that A1 and O1 are subtended by the same chord, and you can also see it as the same arc. And this would be the arc that I'm referring to, BC. But I prefer the chord, it just makes more sense to my brain. And to get the physical size of A1, we're going to use the following theorem. Angle at center is 2 times the angle at circumference, which states that the angle at the center is always 2 times the size of the angle at the circumference, provided they're subtended by the same chord or arc. So the one at the center is always bigger, so A1 will be half the size of O1. And we're going to write up our statement just like this. A1 equals half the size of O1, which is 50. And our reason is angle at center equals 2 times angle at circumference. And then half of 50 gives me a toasty little 25 baht. And your first mark will come from the statement, second mark will come from the reason. And if your brain is better at recognizing shapes, this does form like a bow tie of a shape sometimes. I find that a little bit unreliable because it's not always a bow tie. And there's also a different way we could have approached this question. I could have used angles in the same segment with this bow tie. But this bow tie, all 4 points are on the circumference. With the previous bow tie, 3 points are on the circumference and 1 is at the center. And that's kind of why I don't like getting used to the bow tie for angle at center equals 2 times the angle at circumference, because you can confuse it with the bow tie, which is angles in the same seg. And lastly, we come full circle with this question. We need to get the angle E. Now, if I look at the angle E, it is nested inside of a cyclic quad, my bro. So what do we know about cyclic quads? We know that the opposite angles add up to 180. So these two angles will add up to 180, my bro. And that's going to form our statement, and we're going to clap this oak as our reason. So our statement will read as follows. E1 plus 25 is equal to 180 because of op angles of cyclic quad. Sorry, that should just be an E, not an E1. And then we're going to yoink that 25 over. It becomes minus 25. And 180 minus 25 should give me 155. But don't be naughty, don't take chances. Clap that in the calculator, press equals, and your search agrees. Yes. And your first mark comes from the correct reason. Second mark comes from the correct statement. And just another little nugget of information before I go. You could have used this cyclic quad and you would have got to the same outcome.